So meanwhile, the other students join, we will just quickly have a quick revision of what we studied in the last week. So I explained you what is meant by the latent heat. It is the hidden heat which we keep on supplying while we have to do the phase change. Means when we have to change one state of matter to another, and we observe that the temperature at this particular point does not change. Why does the temperature does not change? Because it is used to
Ma'am, it is used to overcoming the force of attraction between the uh,
right,
particles and so that it does not
and
increase
during
the
the
kinetic
conversion.
temperature. Yes, ma'am.
So basically, it is the heat is used up to increase the rate of the to break the forces of attraction and without increasing the kinetic energy of the particle. Then we discussed about the latent heat of fusion as well as latent heat of vaporization. For
Ma'am,
fusion specifically, we talk about the conversion of solid into liquid, whereas in case of vaporization, we specify
ma'am,
the
liquid into
conversion
gas.
of very good. And
Good evening, ma'am.
then we, good evening, Jitendra, you may keep your video turned on. Then we also discussed about the effectiveness of ice at 0 degrees Celsius in cooling compared to the water at the same temperature. The reason was that the water at 0 degree has more energy compared to ice. So since water has more energy, it is less effective in cooling compared to ice. So then we discussed about the steam, the same thing, why steam is more effective in cooling than the boiling water at the same temperature. Because steam has more energy. Whosoever has more energy will be effective in the heating purpose. So steam has more heat energy. That is why it is effective in the heating compared to the boiling water at the same temperature. Then we also discussed about at what temperature the which state of matter exists, right? Now we have to discuss another important thing, which is about the which I spoke at the end of the class. So, so what according to you would happen, or I would say, is is water pure is water pure if the boiling point observed is 102 degrees Celsius. Who will tell?
Ma'am, may I
Sampath,
tell you?
Sampath, Harshit,
Yeah,
can you tell me if water will be considered as pure if the observed boiling point comes out to be 102 degrees Celsius?
ma'am, I think it's considered pure.
Okay. Yukta, what do you think?
Ma'am, I think so it's considered pure only.
Okay. Jitendra, what do you think?
Ma'am, I think it is pure.
Okay. Rohit, what do you think?
Ma'am, I think it's pure because the main boiling point observed in water is 100 degrees Celsius. So I think
Okay.
it's pure.
Uh, Rayan, Rayan,
Yes, yes,
good evening, beta.
yes. Good evening, ma'am.
Beta, can you answer this question? Will water be considered as pure if the boiling point observed is 102 degrees Celsius?
Yes,
The answer is no. Why? Because the actual boiling point of water is 100 degrees Celsius.
mm,
Whereas we are observing the boiling point as 102 degrees Celsius. So increase in boiling point is due to the presence of impurities.
Okay.
Is it clear to everyone?
Okay. Yes.
And I will
But
continue my
would
class.
it be pure
Yes.
even if it's above 100 degrees Celsius?
1 second. What are you saying? Can you please come again?
Ma'am, but will it not be pure even if it's above 100 degrees Celsius, the boiling point of water?
No. Actually, see, the first and the foremost thing is that if at all anyone ever asks you that in case of chemistry, then how do you check whether a given substance is pure or impure? So in that case, this is the main thing which you have to tell, that if at all the substance melting and boiling point is exactly the same as it is desired, only then a substance is said to be pure, otherwise not. Fine. In case the we talk about the boiling point, it always increases because of the impurities, whereas the melting point always decreases because of the impurities. Okay, so yes, I was saying I will not continue until you people turn on the video. Yukta, Sampath, and Ryan. Sampath, we have not received any message from you. You have problem with mic also. Okay, Yukta, keep your video turned on.
I'm actually, my camera is a bit glitching over here. That's why I'm not owning it.
Then put it in the group.
Yes, ma'am, sure.
Okay. So children, this is what is all about the melting point. As we discussed about the melting, then boiling, then melting point, then boiling point, then latent heat of fusion, latent heat of vaporization, then a few questions related to them. Then an important one more question is, what is the, you may note down these values because this is not given anywhere in NCERT. So you may note it, all of this. Okay. What is the latent heat of vaporization of water? Or even if we speak about the latent heat of fusion of ice, then also in that case also the value remains the same. The answer for this is 22.59 into 10 raised power 5 joule per kg. See, we define it in the same way, that it is the amount of heat required to convert 1 kg of solid to liquid or liquid to gas. So what is the amount of heat? It is 22.59 multiplied by 10 raised power 5 joules. So that means this much amount of heat is required to convert 1 kg of either ice to water or water to water vapors, right? Is it clear, or any doubts? Okay. So let's move further.
2.259 into 10 to the power 6.
Oh, that's one and the same thing, doesn't matter. The value is still the same, no?
Okay, ma'am.
Okay. So now, what is the effect of pressure on the boiling point of the liquid? Effect of pressure on the boiling point of a liquid. Sorry. Boiling point of a liquid. So the boiling point depends on the pressure which acts on it. If the pressure increases, then accordingly, what is going to happen? The boiling point will also increase. For example, water boils at 373 Kelvin at sea level, where the pressure is 1 atmosphere. Whereas on mountains, it boils at lower temperature, where the pressure is less than 1 atmosphere. Am I making it clear? Because the question related to this comes, I'll discuss the question also. So, if the pressure increases, the boiling point also increases. If the pressure decreases, the boiling point decreases. Right? Now, the question which comes to you is, why water boils at less than 100 degrees Celsius on mountain regions? So tell me the answer. Who will be able to tell? I have just discussed this. Harshit, can you tell? Harshit,
Yeah, ma'am. Ma'am, the boiling point. Ma'am, can you
Why
repeat
the
the
boiling point decreases? Because what happens at the mountain region?
Ma'am, the pressure decreases at the
Yes, that's absolutely correct. Very good. At mountain region, the pressure is less than the pressure is less than at sea level. So the boiling point decreases. Am I making it clear? Ryan,
Yeah.
you're able to understand here?
Yes, ma'am.
Okay, very nice. Let's move to the next question, and I will not explain the question nor will I explain the answer. I want the answers from you people. Why cooking of food? Let me see who can answer this question. Food takes longer time on mountains and lesser time in pressure cooker. Who can tell me the answer? Can anyone? Jitendra, Yukta, Sampath, if you know the answer, you may write to me in the chat. I can read the chat. Rohit,
Ma'am, can I?
anyone? Harshit, you
Ma'am,
just answered.
ma'am, because um, if the food needs to be boiled on mountains, the sea level is below the average.
The pressure is less
The
than sea
pressure is
level.
below the average sea level, so it will be difficult to cook the food because boiling water won't be possible.
Acha. And what about that in the pressure cooker?
Ma'am, in pressure cooker, we may, as we use it on gas, it will have higher pressure, so it will get cooked easier.
Right. So at mountain regions, the pressure is low. At mountains, the pressure is low. So it takes time for cooking. Whereas in case of pressure cooker, the pressure is too high. In pressure cooker, the pressure is high, so the food cooks easily. So the food cooks easily. Is it clear to everyone? Jitendra, Yukta, Rayan, Harshit, all
Yes, ma'am.
clear?
Yes, ma'am.
Okay.
Yeah.
So this was all about the fusion and the boiling, which we discussed. Now let us come to the next state change, which is condensation. Now, what is condensation? It is the process of converting the process of converting, or we may write it in the way, the process of conversion of gas to liquid state. So the best and the most easiest example which you have observed in your everyday life is the conversion of water vapors to water. Where have you observed it in the most common times? Whenever the cooking of rice takes place, the water, it starts to boil, then it touches the plate which is kept at the top. The plate is cool, the water vapors uh, on cooling, they convert back into water, which appear as water droplets on the surface of the plate. Am I making it clear to everyone?
Yes.
Okay. So let's move further. Next, we have the next process is solidification So what happens in the solidification? It is the process of conversion.
Conversion of liquids to solids.
Yes, that's absolutely correct. Conversion of liquid to solid state. The best example for this is the conversion of the liquid water to ice. The conversion of liquid water to ice. Fine. Then we have the next process as sublimation, which you are all already aware. We have discussed about sublimation earlier. So sublimation is the process in which the solid, solid directly gets converted to gaseous state on heating without passing through the liquid state. Now we have a few examples of the substances which undergo sublimation. So you have to remember all the examples because each and every example is equally important. The first one is solid carbon dioxide, which is also known as dry ice, because generally the question in this manner is asked from you, which amongst the following does not undergo sublimation, or which amongst the following undergo sublimation. Solid carbon dioxide. Then next we have ammonium chloride. Then next we have, after ammonium chloride, naphthalene balls, which you keep in your woolen clothes. Naphthalene balls. Then we have camphor. Then we have iodine. Then we have anthracene. I think that is all. These are the few substances which undergo sublimation, right? I will quickly show you the process of sublimation as well as deposition occurring simultaneously. I'll first write the definition of deposition. It is just the opposite of sublimation. It is the process, the examples for sublimation and deposition remains the same. So the process of conversion of gases directly to solid state on cooling. I hope the definition is clear. I'll make you see a small video, a very easy one, related to sublimation and deposition, and then we will move forward. Is it done? Okay, let's see.
Wonder why you're not able to speak English fluently? It's because you have not been practicing it.
Welcome to Moo Math and Science. In this video, let's figure out the difference between sublimation and deposition, which are both phase changes. Sublimation is the transition of a substance directly from a solid to a gas without going through the liquid state. Sublimation is an endothermic process. An endothermic reaction is a chemical reaction in which more energy is needed than is released. A constant input of energy
Hello scientific people.
I'm not sure
How are
if
you?
it is
So today I'm going
English
to
or Hindi,
demonstrate
but I think
the sublimation of iodine, and the things required for the experiment are Bunsen's burner, tripod stand, wire gauze for uniform heating. We require a small glass funnel with one of its ends, this thin end covered with the cotton. We require some iodine, and this is our iodine, and I'll show you how does an iodine look like. So there are small balls of iodines which is there in the crucible. This crucible is heat resistant, so it won't break if we even heat till 400 to 500 degrees Celsius. So now let's start the experiment. So now I'm going to mount this entire setup on the Bunsen's burner. So I have ensured that whatever fumes due to sublimation are produced, they must not escape out. So that's why we are putting this cotton over here. So now let's see what is going to happen. As you can see that the purple fumes of iodine have started to come out, and I don't want these fumes to escape out. Now iodine sublimates, that means from direct solid state it will convert into gaseous state, and I don't want these purple fumes of iodines to get out, so that's why we have plugged a cotton piece over there. So we are expecting the gaseous iodine to get collected on the surface of this funnel, and when we stop heating, that gaseous fumes are going to again convert back into the solid state.
you can observe that the iodine vapors are starting to rise.
So now let's lift this and see. Wow, wonderful. Now let me switch off the Bunsen's burner. See the beautiful ring of the iodine which has sublimated, which has resublimated back, deposited on the walls of the internal walls of this funnel. Look at the beautiful ring.
So I hope it was clear. And iodine is purple in clear color. So very clearly the evident purple color, first the fumes were observed, and when the fumes, a few fumes got collected on the surface of the funnel, and when we cool it, it gets converted back into the solid. Not as it would be not as same as which we took in the took initially in the experiment, but then we get the solid form of it back. Clear to everyone? Okay. So children, the next we have, first you should know about this table, the conversion of all the processes written together, because it comes in the exam to fill it. The question comes A, B, C, D, E, F is given and you have to fill it. So first is the conversion of solid to liquid. And after this, we are going to study about the effect of pressure. This was all about what we have studied till now, the effect of temperature. So conversion of solid to liquid, it is fusion. Liquid to solid, it is solidification. Then liquid to gas, it is vaporization. Then gas to liquid, it is condensation. Then solid to liquid, solid to gas directly is sublimation. Children, at some places, if in case of any MCQ or any question, if at all the conversion of gas to solid, you see that sublimation is written, then in that case also, you will not say that, ma'am, it is not correct. Because sometimes in the question it comes, that doesn't mean you will leave the question anytime, because it somehow means the same thing only. Clear, everyone? Then we have the last topic related to the conversion, and then a very interesting topic, which probably we will start in the next class. So, effect of change of pressure. Till now, what we had studied was the effect of change of temperature, in which either we were heating or we were cooling. Now, what we are going to observe or what we are going to study is the effect of change of pressure. So, children, you think and tell me, if I keep on applying pressure to a gas, what is going to happen? When a huge amount of pressure is applied to a gas, it will get compressed, right? On compressing, finally, what is going to happen? Finally, the gas will get converted into the liquid state. But the pressure works only along with the temperature. So when the pressure is applied, means the pressure is increased and the temperature is decreased. When the temperature is lowered, then in that case, the conversion of gas to the liquid state takes place. Fine. So what do we say when pressure is applied and temperature is decreased? We observe the liquefaction of gas. Basically, what does the liquefaction term means? Liquefaction is the conversion of the gas back to, sorry, the conversion of gas to the liquid state on applying pressure. Clear, children? Any doubts still here?
Ma'am, how is oxygen converted into liquefied oxygen?
Okay, children. So also I'll tell you one thing which has been removed from class 9 syllabus now, but initially it was there. So what happens is that air is a mixture of many gases, but it is very much possible to separate these gases. How it is possible to separate these gases? The first thing which we do is this only, that we convert the gas into the liquefied form. Fine. First, we convert the gas into the liquefied form by applying pressure and by decreasing the temperature. There are specific certain temperatures at which the gases gets liquefied. When the gases get liquefied, then they undergo a process which is known as fractional distillation, and there we can separate the gases which are present in the air. Right, Rashid? So in the same way, the liquefaction process helps to convert the gas into the liquid state by applying a lot of pressure and decreasing the temperature simultaneously. Clear?
Ma'am, but I have the doubt how oxygen gets converted into liquefied oxygen.
The same way, by applying pressure and decreasing the temperature, all the gases. This is applicable for all the gases. When we apply a large amount of pressure and the temperature is lower, then the gas gets liquefied, means it gets converted into the liquid state.
Ma'am, if the liquefied state of oxygen is kept in the cylinder and is kept under the sun, nothing will happen, no?
See, if we are storing it, the liquefied oxygen is stored and it is enclosed, then nothing is going to happen. But in case the temperature is increased, then it will get converted back again. We have decreased and then we have to maintain the temperature also. And if you're not maintaining the temperature, you are saying that if we keep it under the sun, then sun means heat, heat means temperature. If the temperature is increasing, then it will get converted back again. The liquid will again get converted into the gaseous state. Huh?
If is it in the cylinder?
So what? It is in the cylinder, but you are providing the temperature now. Then the state change will happen. See, if I take a bottle, in the bottle I put a lot of water. Okay? I put the water in the sun. You will observe that the amount of water will get reduced a little, right? And similarly, if we keep this water in a closed container or in an open container in the refrigerator, in the freezer, then what are we going to observe? That it will get converted into ice, isn't it? So the state change will be observed. It depends what amount of temperature is there, what amount of pressure is there. According to the amount of temperature and the pressure, the conversion amount may differ, but yes, it will get converted. The state change will occur depending on the temperature and the pressure, irrespective of whether it is stored in a container enclosed or open. Only the amount, the rate will differ. If at all it is open, then it will occur faster. If at all it is enclosed, then it will occur slower. Clear?
Yeah.
Okay. So I'll introduce you all to just a new term, just the definition we are going to do today. And then we will do the rest in the next class. So yes. Next we have to study is evaporation. So children, the definition is very much similar to vaporization, but actually the process of evaporation is very different from the process of boiling or vaporization. So what is evaporation? It is the phenomenon of change of a liquid into vapors. Now the important thing is to be noted. At any temperature below the boiling point. Below the boiling point. That is what is the most important thing to be noted. What is the main difference between the process of boiling and evaporation? So children, boiling occurs at boiling point, whereas evaporation can occur at any temperature which is less than the boiling point. Now we are going to see the difference between the evaporation and boiling also. So I'll tell you a few important things about evaporation and boiling in the form of difference. So the first point, it occurs at what we have just discussed, at any temperature less than or below boiling point. Temperature less than boiling point. It occurs at boiling point. There is the boiling point of any liquid is always fixed. So it will occur only and only at the boiling point. Secondly, evaporation causes cooling. I will give you example also, so you will be able to relate to it. Whereas boiling causes no such effect. Boiling causes no such effect. The next and the important point is evaporation is a surface phenomena. I will explain you the meaning of this. And boiling is a bulk phenomenon. Boiling is a bulk phenomenon. So first I'll give you the example of how evaporation causes cooling. Have you ever seen or used a nail paint remover? Ever you have seen a nail paint remover, nail polish remover? If that falls on our hand, we feel a little cold, isn't it? Yes or no?
Yes, ma'am.
So why is it so? Because the nail paint remover which falls on our hand, it takes the heat of our hand and it gets evaporated, and hence we feel cool. This is one of the examples. Then we have written that evaporation is a surface phenomena and boiling is a bulk phenomena. What does this mean? So we take a container in which the liquid is present. So in this liquid, the liquid particles are present at the surface also, and the liquid particles are obviously spread in the entire liquid also. So evaporation occurs only and only at the surface, whereas what happens inside the entire bulk means in large quantity. What happens inside the container is the process of boiling. The evaporation occurs only at the surface and boiling occurs within the entire liquid. Clear, everyone?
Yeah, ma'am.
Fine, children. So we are going to continue the discussion of evaporation, the factors which affect the evaporation in our next class. Everyone revise till this point, and I'll see you all in the next class.
Ma'am,
Have a good day,
Once
children.
more explain what surface and bulk phenomenon is, like difference.
Yes, surface means just at the surface, means what is present at the top, whereas bulk means the entire liquid. Okay?
Yes, ma'am.
We will discuss a little more in the next class.
Ma'am, for evaporation, can we take the process of the pot, how it cools the water?
Process of?
A pot, how it cools the water inside it.
Yes, I will be taking all the example, the applications, all of them which are related to it. Okay?
Okay, ma'am. Thank you, ma'am. Bye, ma'am.
Okay.